Let's go ahead and revisit the last example of f of x equals x squared minus 4x plus 5. That's the function that we want to graph. In order to do that, we need a table of values. So first thing we want to do is find the vertex of this function. So how do we find it? There is a formula which you may or may not be familiar with. X equals negative b over 2a. And this is the formula for finding the axis of symmetry of a parabola. So let's explore what this means. First, let's replace b in the formula with the b term from the quadratic of negative 4, and then negative 4 is just positive 4. And then down in the denominator, 2 times a, we know that the a term is 1, so I replace a with 1, and 2 times 1 is just 2. Finally, we have 4 over 2, or 4 divided by 2, which is just 2. So our axis of symmetry is at x equals 2. Now we know that an x equals equation is a vertical line equation, in this case at positive 2. Now what an axis of symmetry is, okay, that is the line that goes through the vertex of the parabola. Now we don't know where that parabola is on the y, but we do know where it is on the x, and that is at positive 2. So we have the x coordinate of our vertex. Now all we need to do is find the y coordinate, and that is still unknown. However, we do know that x is 2, we just figured that out. And y equals the original quadratic. So I'm going to replace x with 2 and then evaluate. So 1 times 2 squared is 4, minus 4 times 2 is negative 8, and then I just bring down that positive 5, and 4 minus 8 plus 5 evaluates to just 1. So the y coordinate when x is 2 is positive 1, and now we have the coordinates of our vertex at 2, 1, and we can go ahead and plot that point. So to quickly recap what we just did, we found the vertex of this parabola by first using the axis of symmetry formula x equals negative b over 2a to find the x value of the vertex. Then we plug that x value into the original function to get the output, which was the y value of the vertex, and then we had our full point. So now we know that our parabola has a vertex at 2, 1, and we should have a better idea of what our final graph is going to look like. But we still need to find the rest of the points. Now for the x values, I'm just going to build above and below the vertex value. So now for instance, if I want to find the y value when x is 3, I will replace x in the original function with 3 and then just evaluate. So in this case, I would have 9 minus 12 plus 5, which evaluates to positive 2. So when x is 3, y is positive 2, and now I have another point on the parabola. So I'm going to go ahead and plot the point 3, 2. Let's go ahead and find another point. Let's say I want to find the y value when x is 0. I'll replace x with 0 in the original function and then evaluate, and I should just get positive 5. So 0, positive 5 is another point that is on the parabola. And now I can easily repeat this process for the remaining x values to find the rest of the points that are on the graph. Now once I do this, I have a filled in table of values, and all I have to do is plot those remaining points, and we have completed our graph.